Swayam Prabha. Digital India. Educated India.
Center for Non-Destructive Evaluation at IIT Madras aims to build deep research-based non-destructive technologies for improved performance, enhanced safety, and increased life for industrial applications and relevant technologies for societal well-being. Let's know all about it from Professor Krishnan Balasubramanian.
I have many roles I play in this institute. One of the roles I play is I am the founding head of the Center for Non-Destructive Evaluation. So you may be wondering, what is non-destructive evaluation? Non-destructive evaluation, or NDT as often it's called, essentially looks inside engineering materials and structures. Now you can go to a hospital and get an X-ray done. Why? Because you want to know if there is a crack in your bone or if there is something not right in your body. You also can get an ultrasound done, and the doctor may prescribe that and you may get it done. So we exactly do the same thing but on engineering structures. The engineering structures could be a road, a car, a plane. It could be a pipe that is supplying water to you. It could be a pipe that is supplying oil. It could also be the bridges, the dams, and the power plants that supply you electricity. Every engineering structure needs to be validated just the way your body and my body needs to be validated and say everything is okay. Now, how do we do that? We are all opaque bodies. So in order to look inside materials like steel, like concrete, like polymer composites, we look inside material using the physics of ultrasound, X-ray, infrared imaging, microwave imaging, and several such techniques. Once we know what is the state of that material, then a decision can be made as to whether this material or this structure or this component can be prolonged use in the industry. So for instance, if I can tell you that there is something wrong with your automotive engine, you will not have a failure in the middle of a highway. So the earlier we find something is wrong with it, the better it is. But the application is much wider. We also look at it from the manufacturing. So whenever you say you take, for instance, your engine of your car. So engine starts with metal. So steel or aluminum or magnesium, whatever be the material, we start by looking at how good is the material coming out of the metal manufacturing company like a Tata Steel or Aditya Birla Copper. So how is that material good or not, or is there any problem with that material? So right from the incoming material, then you would do a process called as primary process, which is say casting, forging. So you make it into a shape that you want the engine to be. Again, you have to say, did it do it correctly or did it have is there a problem with it? The reason why we have to do it and do it early and find if there is any problem and identify the problem early is because every manufacturing process is expensive. So if I can find something wrong early, then I save a lot of manufacturing costs, and thereby my cost to making this product becomes more affordable. So once say you have done the primary processing, then secondary processing happens. You machine it, you do something called heat treatment in these things. You may drill, you may create shapes, and you may create conduits like cooling channels in the engine. All this again requires inspection, because if it's not done right, then the engine will not function properly. Not only we have to assure that the engine works well on day one when it leaves the factory, it must also work for 10 years, 15 years, 20 years. So we not only have to make sure that the material is perfect when it leaves, but also we make sure that there's nothing that can go wrong in the future. So again, we use the same physics to investigate what is inside and be able to tell. In this process, there's a lot of fundamental research that is involved. We need to understand the physics, we need to understand how the physics interacts with the material, how it interacts with any what we call an anomaly, which is something not right. And then we also must be able to say how good or how bad it is, and how long will it actually survive with whatever state of the material we have. In this fundamental research, our team is rather large. Today we have about 50 to 60 students who work in our center. We have about 8 faculty who are a part of the center, and our center is recently being called the Center of Eminence under the Institution of Eminence category by IIT Madras. So we believe that our center is very well equipped, both in terms of expertise as well as in terms of equipment, to be ranked in the top 3 or 4 in the world. We benchmark ourselves against some of the best in Europe, US and in Southeast Asia. We believe that the kind of fundamental research that we do leads to journal papers that are in some of the best journals in the world. We also get our students, particularly PhD and master's students, who graduate and take up some of the jobs either in academia or in the industry. And more importantly, in the last 12 years, we've been also trying to change the mindset of our students to look beyond just getting a job, but to also look and say, can I look at creating jobs? Can I be on the interviewer side rather than the interviewee side? We have been very successful. We have about 10 startups that have emerged in the last 12 years. Interestingly, these startups are employing about more than 1100 people, and that's averages about more than 100 employees per startup. And some of the startups now are not just in India, they are global. So many of them have offices in the US, in Europe, in Singapore, in Middle East, and we are employing people just not in India. Although majority of the 1100 employees are in India, quite a few of them are also in other countries. So this shows the capacity of an Indian technology or Indian technologies to scale to a global platform. Some of the clients that we have are the best in the world. Example, in the oil and gas industry, for instance, we have ExxonMobil, we have Shell, we have Chevron. All of them are our clients. Another example of some big companies are like the Boeings, the Timkens, the SKF. These are all big manufacturing companies, the Tata Steel in India. These are big companies that are also using our technology, our products, which are something that was researched in our lab, fundamental work was published, then a couple of our students decided that this technology is worth taking to business, and then they have actually created the startup, taken a huge risk on their career front, taken a huge pay cut because industry pays them well if they take a job. A startup initially does not pay too well, but they take that risk, they take the sacrifice, they actually make technology work and work for just not Indian industry but globally. And that is a big challenge that these students are willing to take, and then that is a mindset that we are trying to create in our lab. Today we have several students who are actually looking at how do I convert my PhD thesis or a master's thesis into a product. This entrepreneurial mindset change has evolved over the last 15 years or so. One of the reasons why I believe that we are able to do this is because we get a lot of funding, and a lot of what we do in the lab, that includes equipment procurement, equipment maintenance, supporting students. A lot of it happens because industry is giving us funding to solve their problems. And one of the essential features of a student working in our center is that he or she will be involved in industry related work. They will be involved in fundamental work that will be going towards a thesis, but also will be always involved in some industry work or the other. They gain experience. They know how to now handle industrial requirement. They know how to handle people. They know that they will go and visit these industries. They will actually get their hands dirty. If you cannot do that, then generally we don't encourage our students to be here doing just work in front of a computer or just doing work on a theoretical sense. A lot of our students are involved with industry on a daily basis. Now, whenever we go to industry, that's when this startup ideas is, the genesis happens. We go to industry, and the industry, we may actually go to solve a problem, but then the guy there will say, hey, my bigger problem is this, all right? And then the student may come back and we'll discuss it, and we will say, well, is there a way to solve it? And that's how the whole thing starts. And since we know that the industry really wants this and is willing to pay for it, it becomes a good business proposition. So that is how we get the students interested, because they are always involved in industrial problem solving. And they also start to think differently. They just don't want to only say, can I publish my work? They also start to say, can my work actually help somebody? Can it make a small difference in somebody's life? And that thinking is what I call as entrepreneurial thinking. It's something that we imbibe into our students here. Almost nobody here who has passed through our center can get away by not having this exposure. So exposing them, sort of throwing the baby into the water and let the baby swim, is kind of a common feature in our center. So that's kind of probably the reason why our center has evolved. It also evolves because some of the early startups did very well. So one of the interesting features of this startup ecosystem that we're building here is that the older startups actually become mentors to the younger startups, and the younger startups learn from the experience of the older startups. Doing a startup is not easy, but since we have been successful right from say 2010 onwards, for instance, the first company that came out is a company called Dhwani Research, which actually looks at inspection technology, same non-destructive evaluation for manufacturing industries, whether it is manufacturing industry in the defense sector or space sector or energy sector. They actually produce ultrasonics, X-ray machines that will inspect the rocket motor, for instance. So the next launch that you see going to happen, I'm sure several of these components were inspected by machines that were supplied by this particular company. In about 2015 time frame, the second startup called Planist Technologies took over. Planist was an interesting startup where 4 of our students who were part of our Center for Innovation, and they were in a part of underwater robotics competition. In fact, they did very well in a competition that happened in San Diego in the US. So they came and said, now that we have won a competition, or we've done so well in a competition, is there something that we can do and make a business out of it? And that started the underwater robotics company. Today, a significant number of states in India are actually employing them to look underwater, whether it's a bridge, whether it's a dam, whether it is a storage container. We look inside to see and verify and make sure that the life of those structures can be prolonged. So whenever, for instance, the flooding that's happening in the north today, the bridges, we do not know what is the damage under the water. So we will have to make sure that there's nothing seriously wrong with that, because we have to have trains and trucks cross these bridges. So to ensure safety, this company actually takes its robots, goes underwater, and then tells you how good is the structure under the water. All the robotics, everything is developed by the company in India using Indian knowledge. In 2016, we have a company called Detect Technologies. which is ensuring the safety of large industrial plants, whether it's a refinery, whether it's a steel manufacturing plant, whether it is a petrochemical, whether it's a fertilizer plant. You have to know and keep the plant safe for the people, and safe for the people who are working inside also. So you probably heard many times, certain factories suddenly there's a problem and then everybody around has to be evacuated. So how do we avoid such situations? They use artificial intelligence that has been developed over the last 8 years or so, is being used to identify problems early, solve these problems before it becomes an issue. Since then, we've had several other startups. An example would be Zyma Analytics, which is in sensor IoT business, keeping a lot of industries more efficient. Solinas Integrity, this is a company that helps you get a more high quality water in your pipes, as well as it also has a very unique technology for replacing human intervention into septic tank cleaning, which is a very big social. So whether it's an industrial application, social application, safety, sustainability, environment, in every single facet, the center and its startup is playing a key role. And as I said, it's just not in India. Indian technology developed for India, tested in India, now working globally. That's a big accomplishment from our startups. You see that it has exploded. If this explodes, then what happens is that the plant has to be shut down. Hydrogen being such a valuable material, the company will lose something close to 5 to 6 crores a day. And typically it will take about 10 to 12 days for them to stop the plant, replace the tube, and then restart the plant. So you're talking about 20, 30, 40 crores depending upon which plant it is and how many of these tubes there are. And if we can save the company from this, then the huge economic value to the company. So this is one example of a technology that we are trying to solve. So this is a very good example of an industry problem. This is a tube, it's a part of a tube. This tube is actually about 15 meters tall. This actually produces hydrogen. Everybody today knows what it means when you say hydrogen. You have the green hydrogen, which is the most sought after. Today, hydrogen, when you produce hydrogen, it is expected to be a renewable energy, which means no emission. And more we are seeing hydrogen cars, hydrogen trucks come up. This is a part of many industries, but the problem they have with this is that you have a high temperature environment in which this material, although very expensive and special material, can actually fail. Alright, and I will show you a failed component in a minute. Alright, now this is a problem that we are solving with industry partner Indian Oil Corporation, where we have created this robot. The students and my team here have created this robot which will actually go up and down. There are very special sensors here, and then we get the data and you can see that it's almost a productized version. In fact, these guys have actually gone to several refineries of Indian Oil Corporation, collected data several times over the last 2 to 3 years, improved the technology to a point where this technology is working now. And there is no technology like this in the world. There are similar technologies, but they all have shortcomings. We have looked at those shortcomings and created a technology that works much better. So just to give you one example, today if you have to get a person from abroad to do the same and do this inspection of these tubes, these are called reformer tubes. In one plant of say a refinery, there could be anywhere from 700 to 1000 tubes, and each one of them has to be inspected. Alright, this technology will do that in 2 to 3 days, but if you bring in a person from say US or Europe to do this, the cost of doing this is in 10 crores, 15 crore. While we can do this at a fraction of the cost, and also mind you that this technology solves certain tricky issues that other technologies are unable to solve. So we get more reliability. We also can ensure that the life of these components can actually be prolonged, and thereby you are actually saving material, you are saving energy cost, you are saving lives of people because it's safer. Entrepreneurship is not for everybody. Let's recognize that. 95% of the young people are better off taking a job. You have to be, if you want to be an entrepreneur, you have to make sacrifices. You have to take a lot of risks. So many of you may or may not be in a position to do that. You have to be economically safe, which means that your parents, your family should be economically comfortable. Because in any startup, you're going to go through a little phase where money will become scarce. In many times, you will have to pay salary to your employees, but you may have to go home without a salary. So this is a very critical part that you have to take a call on. But if you have that right mindset to do, then I would say jump in. Jump in early. If you are 21, 22, 23, it's a good time to jump in because you have very little to lose. It becomes harder as you become more responsible when you get married, you have a child, then you have to worry about school. You have less time for this. So the earlier you jump in, the better it is. Take a leap of faith in yourself. Build a team. Okay, usually one person as an individual entrepreneur is often going to struggle. Today, entrepreneurship and startup ecosystem is very complex. There are many things that need to be done. You need to have somebody looking at investment all the time, which means you are talking to people who are going to give you money to do the work. You're going to have to talk, somebody has to look at the technology. And the other important part is you have to look at compliance. You have to be within the framework of the regulation of the country you are in. All this takes full-time jobs. And typically, it's good if the founders are doing this. So it needs minimum in my mind about 3 people, a team of 3 people or 4 people to come together. You should have good chemistry between you, which means that you must have been friends through college or school or whatever it is, or through your initial employment. Then I would say take a leap of faith. If you fail, that's okay, because failure is a part of entrepreneurship, but when you fail, you learn how to succeed, and then you will succeed the second time, maybe the third time, and this degree of success may change, but eventually you will be extremely successful. So if you have the confidence, if you have the team, don't think twice.